Hello, ladies and gentlemen. Root Beer here, and I'm going to be looking at another part two or second part of the Alberta HSMC or High School Math Competition. So we're going to be looking at the 2008 part two of the contest. Remember, this contest is done in 2 rounds. First part, a nice little 80-minute multiple choice contest. So if you're looking for the 2018 part one, or I guess it's 2017 because they write it in November, but from the 2017-2018 school year, I guess. If you're looking for the 2017 part one of this paper, feel free to browse around the channel, but we're going to go through part two in my usual style of one question per video. So there's only 5 questions here. You get, if you're invited to write this, you get 3 hours to do so. And remember, we do need full written solutions, everything sort of explained in detail. And the questions should increase in difficulty as we go down. But I find sometimes when you're writing at this level, it's entirely about what grabs you. You know, if it's a question about combinatorics, even if it's question number 4, that might be a lot easier for you than, say, question 2 that's a particular geometry problem. I don't know. Okay, so in this video, we're going to go through problem number 1 and then problem 2. As I say, if you'd like to try it out, you can get a copy of this contest by clicking the very first link down in the description. So, pause the video, try problem 1 before getting there. Or, if you're intrigued by this contest, download it after this video and try problem 2 before joining me for that one. The difference of 2 positive integers is 18. When we divide the larger of the 2 positive integers by the smaller, the quotient and remainder are equal. Oh, that's kind of interesting property. Find all possible pairs of positive integers. Okay. So there's 2 numbers, but we really only need the 1 variable because we're told how these numbers relate to each other. So maybe you could say something like, let x equal the smaller of the 2, so x plus 18 is the larger. Right? So what we're doing is we're doing x plus 18 divided by x, and then we get a quotient here after all our work is done, and then we get a remainder of r, and what they're saying is the remainder and the quotient happen to be equal. Okay, well, a couple things that we can do here. One thing, to have the remainder, when you say something like 3 into 22 is 7 with a remainder of 1, it's because, 3 goes into 22 7 times, you get a remainder of 1. But it's important to remember, 3 goes into 22 6 times with a remainder of 4. How come we never write that? Well, we're very particular about our remainders. The remainder has to be less than the number we're dividing by. It has to be less than the divisor. So this number is the divisor, this is the dividend, this is the quotient, this is the remainder, just in case you weren't up on the terminology. A lot of people don't talk about dividends. Okay. Anyway, so we're going to have to remember that whatever remainders we come up with are going to have to be less than these x values. Okay? So another thing we can do, we can rearrange. So you can say something like if x plus 18 divided by x leaves a quotient q and remainder r, then what we can do is we can rearrange this into a nice, neat expression. Qx's plus r should be x plus 18, and we should also note that r is between 0 and x, and you can't actually equal x, otherwise you'd be able to get another number out. Okay? So that's fantastic. Now, what could we do? And there's a couple things we could try and do here. So I've got, we could say something like we also know that we know that q is equal to r, because that's in the question. So what have we got? Like x plus 18 is, let's say, qx plus q. Now, one thing we could do, we could subtract x from both sides. Okay. And another thing we could do, we could subtract 1 from both sides. And you'll see why I do that in a moment. Okay. Now I've got some q minus 1s here, and so I've subtracted 1 from both sides. I got 17 over here. Q minus 1 on both sides. Like, we can rewrite this a little bit, taking out a factor of q minus 1 from both of those. And so we've got 17 is q minus 1 times x plus 1. Okay. So, well, q's got to be an integer. X has got to be an integer. So what possible things can we get for 17? And specifically, we want x to be positive. So x plus 1 is positive. So actually, x plus 1 is greater than 1. So how many factors of 17 are greater than 1? I might say we conclude x plus 1 must be equal to 17. As a result, x is 16, and that really seems to be the only one that works. And they really only wanted the values of x, right? Sorry, find all possible pairs. So x would be 16, and then x plus 18, the larger number, would be 34. Okay? And you'd have to get q minus 1 would have to be the other factor of 17, so 1, and so q would have to be 2. So your remainder would be 2 as well. And what you could do is you could check this. Okay? 16 goes in twice, 32, and oh, look at that, we've got a remainder of 2. So this definitely works. And so you could say, well, 16, 34 is the only possibility. Right? We managed to show it because 17 is prime. If we'd gotten something like 12, we would have had a lot more factors, a lot more cases to work with. Okay? So, just to briefly recap this, the reason I sort of approached this is division's kind of hard to work with, but you can always rearrange a division statement into a nice statement with multiplication and adding on the remainder. Okay? And then, well, we get rid of the r. I start trying to get rid of the x's, and I get rid of an x over here, and I'm left with just 18. And then I spy, oh, if I could make this a factor, then I could say, okay, well, x plus 1 or x minus 2 or whatever I got has to be a factor, and that certainly limits the possibilities of x. Okay? And turns out there's only one possibility. Now, another way you could have approached the question, just while we're thinking about things, you could have said, okay, x plus 18, x here, and you get q, you get a remainder of q as well. You could have started guessing and saying, okay, x plus 18 is qx plus q, and then you could have said, well, could q be 1? So you'd need x plus 18 is x plus 1. No way that's happening. How about 2? Okay? And if you subtract x from both sides, subtract 2 from both sides, you'll get x is 16. Okay, great. You could say something, you could start going and just building yourself up with cases. Now, this is a little inelegant, and you probably wouldn't necessarily get full marks unless you gave a detailed explanation as to a good stopping point. So if I subtract 3 from both sides and subtract x from both sides, 15 2x, well, that's not going to happen with an integer. And you can just sort of keep going like this. But you'll find that nothing really works. And so while this is a way to get an answer, and you will eventually exhaust yourself, and you should probably, as I say, add details explaining why you only need to go up to a certain amount, you'll sort of run into... you'll get less marks, I'm of the opinion, if you just do it case-based. I'd say the factoring method a lot more elegant. But case-based work would get you the answer in a pinch. Okay, it really would, but we do want to look for more elegant solutions. Okay? Another thing that we could notice just from the way this is working out, we're always doing 5x plus 5 or 4x plus 4. So you could have started trying to factor out and say, well, q needs to be, we got a factor of q, we got an x plus 18 here, or sorry, not x plus 18, x plus 1. So x plus 1 needs to divide x plus 18, so it needs to go in there q many times. And so what else could you say? Well, then x plus 1 needs to divide their difference. And that's another way to get rid of the x's. Okay? And so there's a lot of ways to sort of eventually get this divide by this factor of 17 method, which I think is probably the preferred way to do the question. But there we go. That's enough talk. There's sort of the inefficient case way. There's this nice factoring way. Either way, we move on and get ourselves ready for question or problem number 2, and I will see you for that in the following video.